Lesson 1 of Chapter 0 is on sets. We're going to discuss set notation and how to describe elements of a set, and also talk about subsets and complements, and eventually get to intersections and unions of sets. So here's an example of a set. It is a collection of objects, and each object in the set is called an element. So if you look closely here, we have a set name. This particular one has a set name of C. Here's a description, the pages in the chapter of a book. And then here's how we write it. We use curly brackets, and what's inside the curly brackets represents the elements of the set. And you can see there's a few more examples below. You can see we've got the students who made A on a test. Looks like we had 3 of them. We had letters from A to H. And you can see those are listed A through H. And then we have set N, which represents the positive odd numbers, and those are listed in curly brackets over on the right. So, to write that Olinda is an element of a set, this is how you'd write it. Now you see that E-shaped symbol, and that represents that Olinda is an element of set A. Example 1, we're going to use set notation to write the elements of each set, then determine whether the statement about the set is true or false. So part A says N is the set of whole numbers greater than 12, less than 16. So how we do that is we use curly brackets. Greater than 12, less than 16, we'd have 3 elements. And then we have to answer the question on, is 15 an element of N? And we would say that is a true statement. Part B, same directions. Use set notation to write the elements of each set, then determine whether the statement about the set is true or false. So V is the set of vowels. So there would be set V, and then that is a false statement. G is not an element of this set. Part C, same directions. Using set notation to write the elements, we have M is the set of months that begin with the letter J. So we'd have January, June, and July. 3 elements in that set. And then this is a false statement because April is not an element of this particular set. Part D, same directions. X is the set of numbers on a die. So there would be set X, and then 4 is an element of this set, so we would say that that is a true statement. Okay, you're going to be doing some problems similar to those right here, circled in red. Moving on to example 2. If every element of a set B is also contained in set A, then it's just called a subset. If you take a look at this picture, you can see that set B is a smaller set and is completely contained within set A. Thus, we use this kind of notation right here. That represents that B is a subset of A. Okay? We also have this square here with a U on it. That represents the universal set. The universal set contains every element possible for this particular problem. So here's an example. We have set A as the numbers 0 through 8, and set B is the numbers 1, 2, and 3. And since 1, 2, and 3 are also located in set A, we would say that B is a subset of A. That's how we'd say that. We also want to talk about complements. So as an example here, if set A represents the universal set, all the possible values, and set B you can see is 1, 2, and 3, then the complement of B, and that's how we'd write it, we'll put this little dash behind it, it's called a prime symbol, would be 0, 4, 5, 6, 7, and 8. That'd be all the elements that are not located in set B. So example 2, We got the universal set is 0 through 9. We got set A, B, C, D, and E. And they're going to ask us questions. The first question is asking us if B is a subset of A. And so since set B has the elements of 5 and 7, and A also has those, this is a true statement. B is completely contained within A, thus making it a subset. Same sets, we got the U, A, B, C, D, and E, and this question asks us to state if E is a subset of D. Well, E contains 6 and 3, D contains 2 and 3, so E is not completely contained within D. This is a false statement. Next, they're asking us for the complement of A, and so the complement of A would be what's inside the universal set that's not in set A. So it looks like we'd have 0, 2, 3, 6, and that's it. So that would be the complement of A, 0, 2, 3, and 6. Next, it asks us to find the complement of D. Since D contains 2 and 3, the complement would have to be 0, 1, and then 4, 5, 6, 7, 8, and 9. That represents the complement of set D. There's going to be some problems here that you're doing that are similar to those. Again, you can see we've got some symbols here. And because of those symbols, this would be a good diagram to take notes on. It's kind of a reference for those symbols. This represents something being an element. This would mean it's not an element. This represents a particular set being a subset of another set. This is the complement. And then in the next video, we're going to talk about intersections and also unions.